Good morning. This is Mr. Eberhard with biology lesson on design diagrams. This goes with assignment ED-3 on the cornfields experiment. Let me take a moment to share my screen. So here we have ED-3. So let's take a moment and read through the scenario. You own a large family farm that produces a bicolor sweet corn, scientific name Zea mays, as one of its primary products. Making a living on a family farm is challenging, and you would like to increase the production of corn per stalk so you can increase your profits. You have been recently introduced to two new fertilizers that have just come onto the market that both claim to increase corn production. These two fertilizers are known as fertilizer X and fertilizer Z. You've been using a brand of fertilizer known as fertilizer W for the past 10 years. This growing season, you have decided to grow 4 plots, 25 acres each, of corn to test which fertilizer, if any, does the best job of increasing corn production. In plot 1, you will plot 10 pounds of corn seed per acre and apply 100 pounds of fertilizer W per acre. In plot 2, you will plant 10 pounds of corn seed per acre and apply 100 pounds of fertilizer X per acre. In plot 3, you will plant 10 pounds of corn seed per acre and apply 100 pounds of fertilizer Z per acre. And finally, in plot 4, you will plant 10 pounds of corn seed per acre and apply no fertilizer to this land. At the end of the 3-month season, you will measure and calculate how many bushels of bicolor sweet corn were produced per acre for each of the 4 plots to determine which fertilizer you will invest in for next season. And below that, right here, we see a summary chart of how the farmer was setting up his experimental plots. So we are going to use this design diagram to organize our experiment, to organize the variables and how we're going to conduct this. Now, I suggest what I like doing best is first do the independent variable versus the dependent variable. Identify the IV and the DV first. So remember, the independent variable is the variable that you are changing on purpose. It's the variable that you are interested in. It's the variable you are testing. So in the experiment up above here, what is the farmer interested in testing? Correct. He's interested in testing the types of fertilizer. Not just fertilizer, you want to be specific. It's not the amount of fertilizer, it's not the age of the fertilizer, it's the type of fertilizer. So you want to be as specific as possible. And then dependent variable, what's he going to measure to know if the type of fertilizer makes a difference? And if we go back to the scenario, when we search, we can see down here that what he's going to measure and calculate is the bushels of bicolor sweet corn produced per acre. That's going to be our dependent variable. The amount of corn produced. And for the dependent variable, always put the units of measurement or the scale that you are going to be using to determine the dependent variable. So in this case, they've told us it is going to be bushels per acre. The next step I like to take then is to look at the levels of independent variable, look at the different divisions of the independent variable. Google Docs won't allow me to split these cells like I can on, like I can on Word. So I can't, if I was writing this, I would just draw lines. But I'm going to divide this into 4 sections because there are 4 different groups. As you can see here, there's 4 different plots being studied. So I would divide this into 4 sections. And so the levels of variable is 1 is going to get the type. See, what types are we using? 1 is going to get the type W fertilizer. I'm going to leave a little space as if I made a box. Another is going to have type X fertilizer, and another is going to get type Z fertilizer, and the 4th one is going to get no fertilizer. If there is a control group in any of these 4 groups, I want to identify it now. So what would be the control group in this experiment? Now remember, a control group is a group that has not been modified or changed, and it's used for comparison purposes. So yes, the plot with no fertilizer is our control group. So I'm going to, in parentheses, identify this as the control group. So if the control group produces more bushels of corn per acre than any of the other 3 test sites, save your money. The fertilizer is not worth it. But if any of the fertilized plots outperform the control group, then you may be onto something worth spending money on. And then trials is how many different groups of each type are you going to set up. So how many groups are going to receive type W? How many groups are going to receive type X? In this case, we're only setting up 1 plot for each fertilizer. So there's only 1 trial in this particular case. So if we asked you to suggest 1 improvement for this investigation, this would be a place where we could definitely suggest an improvement. If it was at all possible, you would definitely want to set up multiple plots for fertilizer W, multiple plots for fertilizer X, and multiple plots for fertilizer Z, as well as your control. But the way it's written, there's 1 trial per group. The other key variable then becomes the constants, the things you're going to keep the same for all plots. All 4 plots are going to have the same things. So some of the things that they talk about that are going to be constants is the amount of seed. That is going to be 10 pounds per acre. So I'm going, if I know the answer to it, I'm going to, in parentheses, define what it is. Not only the amount of seeds, but the type of seeds is going to be kept the same. This is going to be Zea maize, which is the bicolor corn. The amount of fertilizer is being kept consistent, which is going to be 100 pounds per acre. And I'm just pulling this from the reading above. They also have the length of growing season. And it tells me that's going to be 3 months. So everybody's going to be growing at the same time. And I can go back up and search for other things that they are trying to keep the same. The size of the plot is another key factor. "25 acres. Other ones that they don't specifically mention, but certainly would be key, is the amount of water, the amount of sunlight. So if they are going to irrigate and artificially add water, they would want that to be the same for each area. They want to make sure that the growth sites are in very similar locations, so the amount of sunlight is the same, et cetera, et cetera. So with the constants, you want to try to identify the top 5 to 10 constants that would most likely affect the outcome of the experiment. And so there's all of our variables. Now that we have our variables, we can go up and we can create a title and we create a research question. So titles, this is one way to do it. You could just do sort of a plug and go. So you can say something like, to the effects of the independent variable. Well, what's my independent variable? My independent variable right here is the types of fertilizer. So the effects of the type of fertilizer on the dependent variable. What's my dependent variable? The amount of corn produced. On the amount of corn, however, I'm going to add something here. If at all possible, I want to be specific with the genus and species. So in parentheses, I'm going to identify the genus species, which is Zea maize. Typically, italicize the scientific name. On the amount of corn produced per acre over, and the other thing you want to add is the duration, over a 3-month growing season. And so this is typical for a good title. I just plug in the effects of the independent variable, the types of fertilizer, on the dependent variable, the amount of corn, the maize. On the amount of corn, I've got some extra words here, produced per acre over a 3-month growing season. So I'm also defining when this is taking place. Because if you use a different species of corn, it might give you different results. If you use a different species of plant, it most likely is going to give you different results. If it's a 6-month growing season versus a 3-month growing season, or a 3-month growing season versus a 3-week growing season, that also could make a difference. So you want to make sure that you give those specifics. Same thing in the research question. Really, you're just taking the same idea and putting it into question format. But again, you want to include the genus and species, and you also want to include the duration. So the research question might be, which type of fertilizer will produce the largest number of bushels of corn. Again, I'm going to define ZMAs. Per acre over a 3-month growing season. So I'm sort of wording this on the fly. I'm sure if I took a few more minutes, I could come up with slightly better wording. But you get the idea. Which type of fertilizer will produce the largest number of bushels of corn per acre over a 3-month growing season? That's the question I'm asking. That's the question I want to find an answer to. Remember, science is about answering questions. Science is about solving problems. So my job as a scientist is to collect factual information that can provide an answer to that question. Not my personal opinion, not my personal beliefs, not my political persuasion. This is not, all that does not belong in science. This has to be evidence that you can back up and repeatedly show. So then I'm going to make some predictions as to what the answer to that question might be. So remember, we always start with the null hypothesis, which the null always predicts that what you're doing will make no difference at all. And your goal is to reject that hypothesis. So we might say something like, the type of fertilizer will not, let me think a second, the type of fertilizer will not change the number of bushels of corn produced per acre. So doesn't matter what type of fertilizer I use, there's going to be no difference. The control group, type Z, type X, type W, I'd expect them all to be the same. And if that's the data I get, I cannot reject my null hypothesis, and therefore there's no need going much further, and this fertilizer is not worth investing in. End of story. But if any one of those plots produces a significant difference in the number of bushels of corn, then I can reject my null hypothesis and go on to my alternative. My alternative does just the opposite. It says different types of fertilizer will change, will produce, we can do it this way, will produce different quantities of bushels of corn per acre. So in my alternative, I'm predicting that there actually will be a difference. And so if I can reject the null and provide evidence that there is a difference, I then can go further and predict which of the fertilizers I think will have the biggest difference, and ultimately make my decision as to which fertilizer to invest in the next season. So when you look at the finished product, you have a nicely organized plan. This is something that I can look at as the teacher, and within 1 to 2 minutes, I can quickly see if you've got a good plan in place, if you've thought through the key details, and if you're ready to go into the lab and actually carry out the experiment. That's a quick, easy check tool. It's a tool that we will use multiple times throughout the year, and it's one that we're going to have you for homework practice doing for the beginning of next week. So you are going to move on to ED-3. ED-3 is going to provide you with 5 different scenarios, like the corn example, and it's also going to provide you a document with some blank experimental design diagrams, and your task is to take each one of those scenarios and create a design diagram based on that scenario. Also, be aware that each of those scenarios purposely has some flaws or problems in it, because later on you're going to be asked to make some suggestions for improving those experimental designs. Just like in this case, we should have more trials. We should be more specific as to how much water is going to be given or how often water is going to be given. We should be more specific about the amount of sunlight it's going to receive. Those are some ways we can improve this particular design diagram. So hopefully that sets you up to do well. You still need to complete this corn scenario in your own document on Google Classroom. Once you've completed it on Google Classroom, you need to make sure that you do submit it. Thank you much. We'll be in touch later. Enjoy the rest of your day.